The answer is that we can measure resistance across both the terminals using multimeter. So, what happens if we measure the resistance across the both terminals of the transformer? In the step-down transformer, the turns at the primary side is higher compared to the secondary because we want step down, and for that condition the turns should be less. So as more turns means more resistance, as we know the equation for this purpose, R is equal to rho L by A. If rho is constant, as we are using same material, so resistivity will be constant. And area is constant, then only one parameter left for varying the resistance is length, and length is also proportional to the turns. So in step down transformer, the more turns are there, more turns means more resistance. So using multimeter we can measure the resistance and identify which is the secondary and which is the primary side of the step down transformer. Less turns means less resistance. Here we have multimeter. We can adjust to measure the resistance. It usually primary range is in kilo ohm, so we use 20k. Let us see the practical model. As we can see, I connect the testing transformer here to the multimeter, and multimeter shows the reading of 1.8586 between, means it's in a kilo ohm as a 20k, so this is the primary side. We can also test the secondary side. Let us do. As we can see that here I connect the secondary of the transformer, and this is 47 and 46 around. It's where its resistance lays in secondary. So secondary side have a less resistance as less turns are there. So we can say this is secondary and this is primary terminals of the transformer. Note that I have reset this dial to 200 ohms. This readings in 47 ohms, not in kilo ohms, unlike a primary winding. This is whole circuit diagram of our rectifier bridge. Let us see in detail. So it starts from here. 230 volt AC will transform into less voltage 12 volt between these terminals by transformer. The magnitude is higher in the AC wave shape in these two terminals, and the other secondary terminals there is a 12 volt AC, less magnitude compared to the primary, so it's converted into 12 volt AC. Now we have to rectify it, and for rectifier we use rectifier bridge. These whole four diodes are connected such that way we get the one directional current, or say voltage. So this is four diodes we are using. This is called as a full rectifier bridge, and this four diodes is also called diode bridge, generally used for full wave rectification. Let's move to second part. As the voltage is rectified into DC, but what about this gap? We have to fill up by some material that stores energy and give it for that moment. For that purpose we are using a filter capacitor look like this. The filter capacitor is used to give or say to fill this gap and make a whole single line DC voltage. For indication of the power, we are using here an indicator LED. This LED for indication of power is coming. And second thing is that the LED cannot withstand that much voltage through it because it creates too much current through it to flow. For limiting that current, we using 1K resistor. This will drop some voltage and give some voltage to here enough to glow. At the CD terminals, we are getting here a 12 volt output, and one is a common terminal. This whole line is common, or say commonly, as we can get here from this D terminal 12 volt voltage, and for 5 volt voltage we need a regulator. This is 7805. The last two digits indicates the voltage, output voltage at the third terminal of the 7805 IC. So how it's work? 78XX. This is two variables. 78 will be series of the voltage regulator. If here is a 3.3, then the third terminal gives a 3.3 volts. Here we are using 7805 volt. 5 indicates the output voltage at third terminal. Here, this is a regulator, and first terminal is for input, second terminal is ground, and third terminal is our output. So here we are getting 5 volt regulated supply. So here 1, 2 and 3 terminals for that purpose. Second terminal is common for both 12 volts and 5 volts. So in this between two terminals we are getting the variable voltage 5 volt and 12 volt. As per requirement we can use them. That's all. Thank you for watching. If you like, please subscribe my channel and like this video. Thank you.